Okay, so we've got a box of mass 20 kilograms and it's on rest. Notice it says they're on a rough horizontal floor. Okay, then they give us this coefficient of friction. Okay, so we've mentioned it in the previous video here. That measures the roughness, okay, of that contact between the object and the floor. And it says, look, the value is 0.3. So remember I've said that before, okay, it's between 0 and 1. So let's write that down there, okay. So the coefficient of friction, the letter we use is mu, and it's equal to 0.3. The box is subjected to a horizontal force of T newtons. So that's the direction it's going in. Remember then, friction will always oppose, okay, motion. Always will oppose it. So if we go in this way, friction will act as a resistance to hold it back. Okay, so imagine something moving, okay, like your hand sliding across the table. That roughness there sort of slows you down, doesn't it? So it says in A then, given that t equals 65, find the magnitude of the acceleration of the box. Okay, well, first of all, we've got to think about resolving then, okay. And the easiest thing to resolve here, okay, is if we resolve perpendicular to the surface, okay. So perpendicular to the surface. Now, if you think about it, if it's moving horizontally, there's no movement vertically, okay. It stays in contact with the floor. So that means then there's no acceleration perpendicular. So we're in equilibrium. So R will equal to 20g, okay. What's up will equal down, okay. So therefore, R will be 20 times 9.8, which is equal to 196 newtons. Okay, so we've got the value of R there. If we resolve then horizontally, okay, we've got, of course, then we're going to apply Newton's second law here in the direction of motion. And you need to remember that resultant force equals to mass times acceleration. Okay, so we've got the forward force there, T. Now, of course, so we'll write T first. We'll put 65 in now in the next line now, because that's what it is in for part A, isn't it? Take away then the resistance, which is the friction. Okay, and that equal to the mass. Now, the mass was 20 kilograms, wasn't it? 20 times then A, which is what we want to work out. Okay. Now, of course, we know T is 65 in part A. We don't know what friction is, but we can work it out. Okay. So we know that the maximum value is going to be applied for friction. Okay, because it's moving. Okay. So the max value for friction will be mu R. Okay, so remember that formula there. So mu, it said in the question, the coefficient of friction is 0.3 and the R is 196. Okay, so if I work that out, I get 58.8 newtons. Okay, so then all I've got to do is apply it in here. Remember now T is 65. Friction is 58.8. So put that in there. 20 times A. So I work that out. 6.2 is 20A. And then take the 20 over and divide, and I get A out to be 0.31 meters per second squared. Okay. Now in B, it's quite interesting, and it's only worth 1 mark, so it's not going to be much work, but it says, given that T is 45, find the magnitude of the frictional force. So in A, T was 65. Now if you reduce the tension, and they said if you're only pulling with 45 newtons, what would be the magnitude of the frictional force? Now, it's all to do with what we've worked out in A, okay? And look at this line here where it says the max value for friction, okay, and we worked that out, didn't we? 0.3 for mu times the reaction, normal reaction, which is 196. And you've got this. This is the maximum value of friction, 58.8. So in other words, that's the strength that friction has got. That's the maximum strength it's got. Now, if you're going to pull the object with just a force of 45 newtons, okay, well, it's not going to be overcome this, isn't it? So in other words, we could say that 45 newtons is less than 58.8. Okay, so what's going to happen to the object? In this case, we can say that the tension is going to be less than the maximum friction. Yeah. So think about what's going to happen to the object. It's not going to move, isn't it? Object will not move because the tension, the pulling force, is not strong enough to overcome that friction. Now the question asks then, what's the friction going to be? And this is an important step here. The friction, in this case then, okay, it's not going to be 58.8, okay, because that's the maximum value of friction, okay. It will only match the pulling force. So if the pulling force is 45 newtons, the friction will also be 45 newtons, okay. Think about it, it would be a little bit silly if the tension was 45 newtons and then the friction force was 58.8 newtons. It would end up going backwards, wouldn't it? Which is just silly, you know, because there's no force pulling it backwards. Friction is just like a reactive force, okay? It's not like an active force. It reacts to the tension, okay? So we'll only match it, okay? We'll only be able to match the tension there. So its maximum value is 58.8, okay? But in this case, when the tension is only 45, the friction then will just be able to match it and the object will not move.